Welcome to episode 13 of Raff Talks, the podcast where we discuss interesting defense topics each month. Today, we're taking a deep dive into something pretty intense.
Yeah, a literal life or death topic.
Exactly. So picture this. You're a soldier on the modern battlefield. An IED detonates right near your convoy.
Generating a massive flash fire.
Right. You survive the blast, but now you're navigating this pitch-black landscape and you know you're being hunted by adversary drones.
With night vision, of course.
Yes, with night vision. So our mission today is to really unpack the fabrics you're wearing in that exact scenario.
We're talking flame-retardant or FR and near-infrared or NIR technologies.
Because this gear has evolved, It's gone from basic weather protection into highly engineered armor.
It's a massive shift in survivability doctrine. We're now asking a few millimeters of textile to actively mitigate complex physical and sensory threats.
Like simultaneously.
Right, all at the exact same time.
So let's look at the immediate physical threat from that scenario first, the flash fire.
Yeah, the standard approach there is usually either treated cotton nylon blends with a chemical finish or inherently FR air mids.
Meaning the fire resistance is baked right into the molecules.
Exactly. Both of those are designed to be no-melt and self-extinguishing.
But here's where I see a massive flaw in procurement. It's what I call the layering trap. Command issues this top-tier FR outer shell, but what happens underneath?
Well, the operator usually just throws on a standard synthetic polyester base layer.
Because it wicks sweat better.
Right, which completely defeats the whole purpose of the FR shell.
Wearing polyester under an FR shell is it's like wrapping your arm in shrink wrap and then putting on an oven mitt.
That is a horrifying but completely accurate analogy.
Right. The mitt stops the direct flame, but the ambient heat just bakes that shrink wrap straight into your skin.
So you might survive the flash fire.
But you're left with a catastrophic melt burn.
Exactly. The FR protection is really only as strong as its weakest layer. If the system isn't cohesive, it fails.
Okay, so assuming your layers are correct, you've survived the thermal threat. But that explosion just gave away your position.
Which means your priority instantly shifts.
Right. From surviving a fire to visual evasion in the dark. You have to escape.
And the dark isn't really dark anymore. Adversary image intensifiers operate in the 700 to 1100 nanometer spectrum.
Which we can't see.
Right. So if a uniform uses standard dyes, it might look perfectly camouflaged to the naked eye in daylight.
But at night,
it's going to glow like a beacon at 850 nanometers.
But let's clarify a really dangerous misconception here, because I see procurement officers conflating visual evasion with thermal evasion all the time.
Oh, yeah.
Like spectral engineering of dyes to match the reflectance of a forest does absolutely nothing against FLIR, right?
Spot on. NIR and thermal rely on entirely different physical principles.
Because NIR just defeats image intensifiers.
Exactly, by mimicking the ambient reflectance of the terrain. FLIR detects emissivity.
So your body heat.
Right. A uniform that masks you from an NVD provides zero protection against a thermal sensor. Assuming one defeats the other is a fatal blind spot.
Which brings up the reality of the operating environment. You can engineer the perfect suit that stops fire and mimics NIR reflectance, but if it's stiff and heavy...
And doesn't breathe?
Yeah. A soldier operating in sub-Saharan Africa is going to strip it off to avoid heat stroke.
And when they strip off that gear, they're suddenly exposing their skin to a totally different enemy.
Bugs.
Yeah, vector-transmitted illnesses. You solve the thermal and sensory problems by creating a biological one, like malaria.
So comfort directly dictates safety.
Absolutely. Because protection that isn't worn provides no protection.
When you look at how the industry is actually trying to solve this, you see platforms like Raff Elite moving away from piecemeal gear.
They aren't treating these threats in isolation anymore.
No, they're bonding the FR properties, the terrain-specific NIR-compliant dyes, and even permethrin treatments right at the fiber level.
It's an integrated survivability system. The soldier doesn't have to choose if they want to survive a flash fire, evade an NVD, or fend off disease.
It's all engineered into a single wearable platform that actually remains breathable.
It proves that modern military procurement isn't just about buying textiles anymore.
You're investing in complex armor, which leaves you with a pretty wild question. If today's uniforms can defeat invisible light and self-extinguish blast fires, how will future textiles actively adapt to new, undiscovered sensory threats?
That is the big question.
It really is. Something for you to mull over. For defense ministries and security organizations looking to stay ahead of that curve, staying connected with Raff Military Textile for early specification consultation and sample evaluation is your best next step.
Highly recommend reaching out to them.
So keep questioning what you can't see, and thanks for joining us on this deep dive.